Hmm. Hello students, I welcome all of you on my YouTube channel once again. So here I am recording a video lecture series for IIT preparation for mathematics. So again we will solve one more IIT problem which is based on the equating real and imaginary part from the both sides. So here 2x square so now here on the LHS part, this is our real part, and on the RHS, this is our real part. And again on the LHS, this whole is our imaginary part, and again on the RHS, this is imaginary part. So now we will equate both equations. So 2x square minus 3y equals to 2x minus 3y. So x square minus x equals to 0. So now we have answers x equals to 0 and 1. And now we will equate the imaginary part. 3x square plus 2y equals to 5. From here we will have the solution for y. Y equals to 5 by 2 and the other value is 1. So now the solutions for this other equation are x equals to 0, y equals to 5 by 2. And the other one is x equals to 1 and y equals to 1. So I hope you have got the concept of real and imaginary part in a complex number. So now we will see some basic operations of these complex numbers. So firstly, addition. So in the addition, if we add z1 equals to a1 plus ib1 and z2 equals to a2 plus ib2. So now add z1 and z2. So now we will add once real parts at a1 and a2, and then again we will add imaginary part I b1 plus b2. Okay. So now the next one is subtraction. So z1 equals to a1 plus ib1, z2 equals to a2 plus ib2. So z1 minus z2 equals to a1 plus ib1 minus a2 plus ib2. So it will come a1 minus a2 plus I b1 minus b2. So now the next is multiplication. So z1 into z2 equals to a1 plus ib1 a2 plus ib2. So it will be a1 a2 minus b1 b2 and plus I b1 a2 plus a1 b2. So here this is the real part and this is the imaginary part. Okay, so these are the basic operations, and also the last one, so it's your homework. So you find what will be the expression for this z1 upon z2. Okay, so it's your homework. So I think you have got the idea about the addition, subtraction, multiplication operations on these complex numbers. So now, before ending this video lecture, we will see some more IIT problems, so that you have more idea about how to apply these complex number concept on the directly to the IIT problems. So the problem is 1 minus I to the power n and 1 upon I to the problem n. So now what we will do, so here what we will do, we will multiply with I on the both. So 1 minus I upon I square, and as we know that value of I square equals to minus 1. So using this value here, 1 minus I power n, 1 plus I to power n. So now 1 minus I, 1 plus I, the whole power n. Okay, so what is this? A minus b, a plus b. So use this basic formula, a minus b into a plus b equals to a square minus b square equals to 1 minus I square to power n. And what is I square again? Minus 1. So it will be this. So this is your required answer. Okay. So one more problem we will see, and these problems are directly from the IIT JEE papers. So the next problem is 1 minus 2i upon plus 4 minus I 3 plus 2i. So what we will do here, we will solve these two individually by making their complex conjugate. So 1 minus 2i upon I into 2 minus I upon 2 minus I. So it is a complex conjugate, and here 4 minus I and 3 plus 2i into 3 minus 2i upon 3 minus 2i. So it is the complex conjugate for this one. Okay. So after that, it is your homework to solve. One step I will solve. After that, it will be your homework. So 2 minus 2 minus 4i minus I upon 4 minus I square plus minus 2 minus 3i minus 8i upon 9 minus 4i square. After that, minus 5i upon 5 plus and minus 11i upon 13. Okay. So what will be answer here? So what will be the answer here? Equals to by 13, and here plus I minus 11 by 13 and minus 1 equals to 10 upon 13 plus I minus 24 upon 13. Okay. So it will be by 15 minus 24 by 13 iota. So this is your required answer. So if you want to solve this question, you pause the video up to the point where I have started to solve this problem, and otherwise I have solved this problem for you. Okay. So remember the concept of complex conjugate, how to write the complex conjugate. So imagine you have one number a plus bi. So the complex conjugate will be a minus bi. Okay. Complex conjugate will be a minus bi. And the use of the complex conjugate is that we use this complex conjugate for making our equation easier. So thank you so much, and it's my humble request that if you can forward my videos and my YouTube channel as much as you can, I will be thankful to you. Thank you so much.